Beginning Unit 6, we're talking about polynomials. And polynomials are problems like you're used to seeing, like you dealt with in Unit 4, like x squared plus 3x plus 7. That would be considered a polynomial. And each of these polynomials have different pieces. So a polynomial is a sum of terms. So it's a bunch of things added together. That's what sum means. And each term must be in the form of ax to the n. And this would be called a monomial. So each of these things is a different piece of the monomial. So starting with the a, well, our a would be our coefficient. It is any number in front of a variable. X is going to be our variable, and it may be x, it may be y, it may be q, it can be whatever we want, but it's a variable. Nonetheless, it's a letter. It represents something we don't know. And then our n is going to be our exponent. And if we put a bunch of these monomials together, like in the problem below, 8x to the third plus, 8x to the sixth plus 2x to the fourth plus x squared minus 10, each of these has a different piece. So a polynomial is in standard form when all of its terms are written in order from the highest power to the lowest power. So that means from the biggest exponent to the lowest exponent. That means it is written in standard form. Once it's in standard form, you have what's called your leading term. The leading term is the one with the highest exponent, the highest power, which is 6, and you have what's called the constant. The constant is whatever doesn't have x with it, so without a variable. Alright, so a couple of rules. If a term doesn't have a number in front of it, then the coefficient of that term is a 1. So if we're looking at this problem, we have 2x cubed plus x plus 3. That means the coefficient of x is 1. There's an understood 1 there in front. The coefficient of a constant term is the actual number itself. So the coefficient of 3 here would just be 3. And if a power is missing, so in this case there is no x squared, then the coefficient of that power is 0 because it doesn't exist. So there's a couple of things that make something not a polynomial. So it's easier to see what makes it not a polynomial. So if we look at this first one, it says no variables in the denominator of a fraction. So this would not be a polynomial because we have this x in the denominator. So an example of a polynomial would just be 2x minus 5. So the second thing that makes it a polynomial is that it only has whole number exponents. So an example of not a polynomial would be 2x to the 1/2. Well, that's not a polynomial because that exponent is a fraction. So an example of a polynomial would be 2x squared. Another thing that makes it not a polynomial is that it has radical signs or square root signs. So the square root of x minus 5 plus 7 would not be a polynomial because there is this square root sign there. And an example of a polynomial would be x minus 5. There's no square roots. The last thing is it only has real coefficients. Well, this would not be a real coefficient because you can't take the square root of -4. So an example of a real coefficient would be like 4x minus 5. There's a couple other things I want you to write down. So not polynomials. We're going to summarize this and we're going to add a few things to it. So not polynomials if there is an x in the denominator. It is not a polynomial if your exponent is a fraction. It is not a polynomial if your exponent is negative. That's another thing that would make it not a polynomial. And it would not be a polynomial if it had an exponent that was a decimal. There's another example. So x to the 4.3 would not be a polynomial. Or if it had the square root of x because of that square root symbol there. So these are the things that make them not polynomials. All right, so depending on the type of polynomial tells us a little bit about its graph. So when they ask for the degree of the polynomial, they haven't really talked about this yet, but this is very important. So the degree of the polynomial is whatever the biggest exponent is. Okay, so if our problem had x to the 5th in there and that was the biggest exponent, then it would be a degree of 5. So if it has a degree of 0, which means that it's just a constant, so for example, if our equation was just 3, our polynomial just had the number 3, then it's going to give us a horizontal line. Okay, any number that's just a number by itself is going to be a horizontal line, like this. Okay, if it has a degree of 1, that's going to be a linear graph. For example, 2x plus 3. It's going to be a line, but it's going to be a diagonal line. Anything with a degree of 2 is going to be a quadratic. It's going to be like x squared plus 4x plus 3. Its graph is a U, a parabola. Anything with a degree of 3 we would call a cubic. So like x cubed plus 4x squared minus 7x plus 2 would be a cubic. Its graph, it says it looks like an S, which it does, but I'm going to draw you a picture. It's going to look more like this. If it's a quartic, that means it's a degree of 4. So for example, x to the 4th plus 7x cubed plus x squared plus 2x minus 1 would be a quartic. It's going to be a parabola as well. It's going to look a little bit different than the square though, because it's going to be a little flatter at the bottom, but it's still going to have that same U shape. A quintic is anything with degree 5. So x to the 5th plus 4x to the 4th minus 3x cubed plus x squared minus x plus 4. And its graph is also going to be an S-shaped graph. So the question number 1 says, how do you evaluate polynomial functions? Well, if you're asked to evaluate it, that's where they may say find f of 4. And what you do in these cases is you plug in a number for x. And then how do you flip a function over a horizontal line? Well, what happens is you end up reflecting, but you also switch the sign of the y's. We'll talk about that a little bit later. So we have this idea that the end behavior, that's how it acts at the end, is how the graph of function looks on the right sides of the xy plane. And you can predict the end behavior of a function by studying its leading term. So as long as you know what the leading term is, remember that's the first term with the biggest exponent you can tell what the graph's going to look like. So there's two things you need to note. You need to know whether that term is, the coefficient is positive or negative, and the degree, if the degree is even or odd. And I'm just going to write E and O there for space because I don't have a lot of space. So if our coefficient is positive and our graph is even, then they're both going to go up. It's going to open up like this. So this could be x squared, x to the 4th, x to the 6th, etc. If we had a graph whose coefficient was negative and whose degree was even, then they're both going to go down. So it's going to look like this. Again, that could be x squared, x to the 4th, x to the 6th, whatever. Now, if we have a coefficient whose term is positive, so notice they have this 7x cubed here, so 7 is positive. The 3 is odd, so that graph is going to start down and end up. It's going to look like this. It's going to curve from left to right. It's going to curve up. And if our leading coefficient, like this one, negative 3x squared, is 3x cubed, and the exponent is odd, then it's going to start up and end down, and it's going to look like this. Don't worry, I'm going to summarize this for you in a minute. Okay, so here's an easy table to figure out. So the leading coefficient. So I'm going to make a table here. If our leading coefficient is positive, and the exponent is even, anytime it's even, they're both going to open the same direction. So if it's positive, they're opening up. If it's negative and even, it's going to open down. Now remember, what it's talking about here is the coefficient must be positive, but negative. The exponent, the even or odd, has to do with the exponent. Okay? Positive and negative is the coefficient. The even and odd is the exponent. So it can also be positive or negative and odd. If it's odd, it's going to make an S curve. If it's positive, it's going to curve up. If it's negative, it's going to curve down. I should have drawn a better picture for this one, so let's go back and fix that. Alright, so the first thing we're going to do in our checkup is rewrite the polynomial in standard form. So standard form means the exponents are written in order, from big to small. So if I look at this problem, I have 3 plus x squared plus 4x to the 5th plus 3x cubed. So my biggest exponent is 4x to the 5th, so that's going to come first. The next exponent would be the cube, so 3x cubed. The next biggest exponent would be x squared, and then we have our 3. So a couple things I want you to write about this. The degree doesn't ask for this, but I want you to write it anyways. The degree of this polynomial would be 5, because the biggest exponent is 5. And then our leading coefficient, I'm going to write this on the side because I'm almost out of space. Our leading coefficient would be 4, because it's the first number here. Okay, one more thing I want you to write down, and I know you're probably almost out of space, but you'll find room for it. Alright, if we were to list out our coefficients, so we're still doing problem 1, I'm just out of space, so I'm writing underneath problem 2. If we were to list out our coefficients, well, in order, the first coefficient is 4, because that's the coefficient of x to the 5th. When I list out my coefficients, I have to list every single possible coefficient from x to the 5th down. So x to the 5th, x to the 4th, x to the 3rd, x squared, x, and then none. So there's no x to the 4th here, so my next coefficient would technically be a 0. The coefficient of x to the 3rd, well, that exists, it's 3. The coefficient of x squared, there isn't a coefficient there, so we can put a 1. The coefficient of x, well, there is no x term, so that coefficient is 0. And then the 0 coefficient is the number by itself, which is 3. So this would be your coefficients for this problem. Number 3 says evaluate the function below for x equals 3. Well, we said that to evaluate means to plug in. So we could rewrite this as f of 3. But all it really wants us to do is replace every single x in the problem with a 3. So 2 times 3 cubed minus 4 times 3 plus 7. We're just going to plug in the calculator, and we're going to get 49. Okay, number 5, we're supposed to choose the correct graph. So which of the following graphs represents a quintic function? Remember, quintic is x to the 5th. So if we think about 5 is an odd function. That means it's going to be an S curve. There's only one of those, so that would be A. Just as a review, let's figure out what B, C, and D would be. Well, B would probably be a quadratic it for sure is going to be an even function. So it could be x squared. It could also be a quartic. It could be x to the 4th, or it could be x to the 6th, anything like that. A horizontal line is going to be a constant function. Remember where that's just a number, like 2. And this other one is going to be a linear function. D is linear because it's just a straight line, so it's going to be like 2x plus 3 would be an example of a linear function. Number 7, which graph could have created this function? Well, let's look at our end behaviors. So both of these are pointing up. They're pointing the same direction. That means it has to be even. So that means our biggest exponent has to be an even number. So what can it not be? It can't be the 4th one because this has 4x cubed in there and it can't be the case. So the next thing is they are both pointing up. So that means that it's got to be positive. Our leading coefficient has to be positive. Well, out of the 3 that are left, there's only one that's positive, so this has to be the graph of 2x to the 4th plus 5x cubed plus 2x squared plus x plus 1. Now, you can always graph this in your calculator and figure it out. That is perfectly fine. But we're going to do number 9 as well. Describe the end behavior of the given function. On the left, does the graph start low or high? And on the right, does the graph does the graph end low or high? Sorry. So we're going to look at 2 things. We look at the sign of the leading coefficient, so it's positive. And we look at the exponent, whether it's even or odd, and it is odd. So if it's positive and odd, remember it's going to look like this. So that means it's going to end, or it's going to start low, start down, and it's going to end high.